Imagine a gadget you can build for 40 bucks that pumps out power 247 without gas, sunlight, or a battery bank. It operates in pitch black, easily outlives a massive 15 grand lithium wall unit, and can keep your fridge running forever when it hits peak capacity. The crazy part? The science behind it has been rock solid since the 1830s, yet you won't find it on a single government rebate list. It is known as a permanent magnet generator. Stick around because we are going to break down exactly what this is, the science that makes it tick, and how you can put one together yourself. Let's get started. Right now, the standard advice for gaining energy independence is to drop 10 to 15 grand on rooftop solar panels and a heavy lithium battery. But let's break down the real price tag of that system and why it usually quits right when you need the power the most. An average home solar setup in the US runs anywhere from $20,000 to $35,000 before any government kickbacks. Even with those tax credits, you are still handing over 14 to 24 grand of your own cash. And to actually use that power at night, you need storage. A system like a Tesla Powerwall will set you back about $12,000 installed, giving you 13.5 kilowatt hours of usable juice. That might keep your basic home appliances running for half a day, and then you are right back to relying on the city grid. Oh, and forget about maintenance costs in those slick sales pitches. Solar panels slowly degrade over time. Microinverters break down. Wires corrode. Most rooftop setups need a repair guy called out within the first 7 years. But here is the dirty little secret they hide. Lithium iron phosphate batteries lose about a fifth of their storage capacity in just 10 years. Buy a battery today, and by 2036, it will only hold 80% of what you originally paid for. Your 15-year-old solar panels might still be working, but the battery you need to catch that energy will already be dying. When it finally goes, replacing it will cost you just as much as the first one. Now, contrast that massive recurring expense with a little piece of hardware you can hold in your palm. A permanent magnet generator made from roughly $40 worth of basic materials. We are talking about a stack of neodymium magnets, a roll of copper wire, 2 steel discs, and a single bearing. No gas is required, no chemicals break down over time, no forced software updates, and there is no finicky inverter to fry. It starts making electricity the second something turns it. A slow-moving creak, a gentle breeze you can barely feel, or even you cranking it by hand in the middle of the night. Once you realize how incredibly cheap this is to run every month, it makes perfect sense why the utility companies keep quiet about it. And please understand, this isn't some backyard science fair project. The exact same physics running this little device is what powers every massive hydroelectric dam, coal plant turbine, and nuclear reactor on the globe. The only difference is the size and the use of specific magnets that weren't even invented until 1982. So, how exactly does a cheap pile of magnets and wire create actual usable electricity? It all comes down to a rule called Faraday's law of electromagnetic induction. To keep it simple, when you move a magnet past a coil of copper wire, the shifting magnetic field forces electrons to move through that wire. That flow of electrons is what we call electricity. The way the magnet moves doesn't matter. You can spin it, slide it, or shake it up and down. If a magnetic field is changing near a conductor, a current is created. This isn't just a theory. It is the fundamental rule every single power plant relies on. If you think a home-built version couldn't possibly generate enough power for anything real, researchers at the University of Strathclyde in Scotland decided to test exactly that. They hooked up handmade Axial Flux permanent magnet generators and discovered that a properly tuned build could crank out up to 1,200 watts in a moderate wind. That is plenty of juice to run a standard fridge, keep a bunch of LED lights on, and charge your devices all at the exact same time. And the crazy thing? The unit they tested was thrown together using scrap steel, hand-wrapped copper coils, and standard neodymium magnets you can buy anywhere. The actual name for this setup is an axial flux alternator. Picture it like a magnetic sandwich. You grab 2 round steel plates and stick strong neodymium magnets around the edges, flipping the poles as you go. North-south, north-south. Right in the middle of those 2 plates, you place a ring of copper coils, each made from tightly wound, thin wire. When those outer magnetic plates spin, The alternating poles rush past the copper coils and whip up an alternating current. There are no brushes to wear down, no messy gears, and no electronics to fry, just magnets, wire, and movement. But it actually gets cooler. The highest-end version of this setup ditches traditional ball bearings completely. Instead, it uses magnetic levitation. By taking ring-shaped magnets and facing the same poles toward each other, the spinning centerpiece literally floats in mid-air on a cushion of repelling magnetic force. This wipes out mechanical friction almost 100%. A normal wind turbine needs a breeze of at least 3 meters per second just to overcome its own bearings and start turning. A hovering maglev version wakes up and starts making power at just 1.5 meters per second. That is barely enough wind to flutter a flag. And since there are no bearings to grind down or grease to dry up, a maglev generator could easily run for decades without a single tune-up. Some engineers even think large-scale versions could last 500 years. The takeaway here is simple. Regular turbine bearings are a ticking time bomb. Swap them for magnets, and you stop the clock. Plus, the power you save by removing that friction is huge. A standard small turbine wastes up to 30% of the energy it catches, just dragging its own bearings, especially in light breezes. Right when the wind is dying and you need every single watt, friction steals your power. Magnetic levitation completely plugs that leak. Now, here is what should really make your blood boil. None of this is cutting edge. It isn't experimental. This is rock-solid science that we have understood for almost 200 years, and yet almost nobody is building with it. To get why that is such a big deal, we have to rewind to the very start. The first time anyone ever wrote about magnetic pull was around 600 BC. A Greek thinker named Thales of Miletus spotted a heavy, dark rock that could pull bits of iron toward it without physically touching them. He called it a lodestone. He had no clue how it worked. In fact, he thought the rock was alive and had a soul. But he wrote it down, making it the first recorded sighting of magnetism in Western history. Meanwhile, way on the other side of the planet, scholars in China noticed the exact same thing around 300 BC. They named it the compassionate stone, since it seemed to reach out and pull the iron into an embrace. By the 2nd century BC, they turned that magic rock into the very first magnetic compass. You had two massive civilizations, miles apart with no way to talk to each other, both stumbling onto the exact same invisible power. But turning that neat parlor trick into usable electricity took a long time. It finally happened on the 29th of August, 1831, down in a London basement. A self-taught guy who used to bind books for a living, named Michael Faraday, changed history. He wrapped 2 separate coils of copper wire around an iron ring, hooked one up to a crude battery, and watched as the needle on a meter connected to the other coil twitched. He had just proven electromagnetic induction. A few months later, he built the first true electric generator, just a copper wheel spinning between the ends of a horseshoe magnet, pushing out a steady electric current. Every single generator made since then, from the giant turbines at the Hoover Dam to the alternator inside your truck, is just a giant version of that exact experiment. However, Faraday's magnets were incredibly weak. Natural lodestones and early metal magnets struggled to hold up a single paperclip. It took another century and a half before magnets got beefy enough to make a small, at-home generator actually practical. That game changer finally arrived in 1982. Over in an Osaka lab, a Japanese scientist named Masato Sagawa was trying to fix a pricing issue. The best magnets back then were made of samarium and cobalt, which were incredibly rare and very expensive. Sagawa thought he could swap them out for neodymium and iron, 2 metals you can find almost anywhere on Earth. His bosses didn't buy it, so he quit. He moved over to a new company, and within a single year, he created a brand new material, neodymium iron boron. Crazy enough, at the exact same time, a researcher in Detroit named John Croat figured out the exact same recipe independently. They had absolutely no idea the other guy existed until they both showed up to the same science conference in Pittsburgh in late 1983. Everyone in the room suddenly realized 2 guys, worlds apart, had just invented the exact same supermagnet. It was 10 times more powerful than the old stuff, small enough to fit in your pocket, and cheap enough to pump out by the millions. The neodymium magnet changed the world forever. And yet, 4 decades later, The number of American households powering their homes with a generator made from these magnets is basically zero. This tech isn't fake. You can order the exact magnets you need right now for 12 bucks. Every university physics lab on the planet confirms the science is sound, yet it sits untouched by the mainstream. But if you know where to look, you can find people actually using it. Take the Scoregg Peninsula up in the harsh Scottish Highlands. A tight-knit community of about 70 people has been living completely disconnected from the grid for more than 4 decades. No power cables, no paved streets, no gas pipes. All their electricity flows from handcrafted permanent magnet generators. The guy behind most of them is a man named Hugh Pigott. He moved out there in the 70s when there was zero electricity, so he just started building wind turbines out of scrap metal and hand-whittled wood, and he never quit. His setups rely on those same axial flux generators using neodymium magnets, copper coils wrapped by hand, and simple steel plates you can slice up with basic garage tools. Over 40 years, he perfected these builds and published an open-source guide called a Wind Turbine Recipe Book. By 2021, DIYers in over 25 different countries had used his plans to build over 1,000 turbines. By the way, if you want the full blueprints and honest material lists to take your own home completely off-grid, check out the Passive House files available online. It is the absolute best way to start slashing your utility bills right now. Meanwhile, over in a village called Nashdafan in northeastern Iran, there are 30 clay and straw windmills that have been crushing grain using nothing but vertical wooden blades for around a millennia. Known as asbads, these are the oldest working wind machines on the globe. They take the brutal summer winds of the region and turn them into pure mechanical power to spin heavy grindstones. No gears, no metal bearings, and zero electronics. Together, they still grind out roughly 300 pounds of wheat every windy season, and they were spinning hundreds of years before Europe ever built its first windmill. Fast forward to 2024, and researchers at the New Jersey Institute of Technology tested a modern, magnetically levitated vertical wind turbine powered by a direct-drive neodymium generator. The results? Their maglev prototype crushed it. It boasted incredible efficiency, spinning in breezes so light that a regular ball-bearing turbine wouldn't have even twitched. Best of all, the materials to build this cutting-edge prototype cost less than $200. So, we have physics that date back 2 centuries, magnets that have been on store shelves since the 80s, and open-source plans proven all over the world. Why on earth isn't this standard on every house? It is not some shadowy conspiracy. It's the bureaucratic structure itself. Once you notice it, you will see it everywhere. Let's start with zoning laws. Most U.S. towns cap residential structures at a 35-foot height limit, but to catch smooth, usable wind, your turbine has to sit 20 to 30 feet higher than the tallest obstacle within a 300-foot radius. In a normal suburb packed with 2-story homes and big trees, that means you need a 60-foot pole. Since your local code says 35 feet, your project is outlawed before you even dig a hole. Add in setback rules, which demand a tower sit far away from property lines, usually a bit more than its total height. On a typical quarter-acre lot, that rule alone eats up your entire yard. The science is completely sound, the turbine is safe, but the law says your yard is too small. Then you have the electrical code. National standards demand that any power system hooked to the grid use an inverter certified by a recognized testing lab, like UL. A DIY generator wired up to a battery bank will never have a UL sticker. Earning that certification costs tens of thousands of dollars and is meant for mass-produced factory goods, not a custom garage build. So, even if your rig is perfectly safe and highly efficient, the local inspector legally cannot sign off on it. Don't forget about homeowners associations. A recent survey showed over 74 million Americans are stuck under HOA rules. The vast majority of these neighborhoods have strict bans on anything that changes your roofline, adds exterior structures, or alters the neighborhood's look. Even the quietest, smallest wind turbine violates those contracts, and taking an HOA to court will quickly drain your bank account. This happens in the real world. In 2001, a guy named Bob Loblins out in Massachusetts actually got a permit to put a small turbine on his farm. 3 months later, halfway through the build, the town yanked his permit because some neighbors whined about it. He had to fight a brutal 13-month legal war, hire expert witnesses, and burn through thousands in lawyer fees. He eventually got the permit back, but the lesson was obvious. Even when you are legally in the right, the bureaucracy is designed to bleed you dry. The grid wasn't designed to explicitly crush magnetic generators. It was just built around massive, centralized power plants, standardized retail gear, and expensive certified installers. Anything that doesn't fit neatly into that box, no matter how cheap or effective, gets ignored. They don't have to ban it, they just exclude it. And getting excluded works just as well as an outright ban. We are constantly fed the narrative that true energy independence demands a 20-grand solar array, a $12,000 lithium box, and a licensed contractor to hook it all up. That is the pricey, overly complicated route prone to eventual failure. The simpler alternative is a permanent magnet generator constructed from $40 in basic supplies. It revolves on a magnetic cushion that refuses to degrade, powered by free wind. The modern grid simply wasn't set up to embrace something like this. But you don't need the system's permission. Here is exactly how to assemble one yourself. The beating heart of this generator is the magnet rotor. You will want 12 to 16 neodymium disc magnets, rated N42 or better. The standard size is 20 millimeters across and 10 millimeters thick. A dozen of these from a reputable supplier will set you back maybe $15 to $20. You attach these, alternating the north and south poles, onto two steel discs. Any local fab shop can cut these from quarter-inch mild steel plate for about $5 to $8 a pop. Next is the stator. This is the piece that stays completely still and houses your copper coils. You need 9 individual coils, hand-wrapped, using 20-gauge enameled magnet wire. A 200-foot roll costs around $10 or $12. Just wind each coil about 120 times around a basic wooden block. Once they are wrapped, you lock them into a flat disc shape by pouring liquid polyester resin over them in a simple mold. A small batch of resin costs roughly $6. For a standard setup, the only other thing you need is a bearing. A sealed bearing ripped out of a junked car's wheel hub does the job perfectly and costs absolutely $0 if you salvage it. If you want to step up to the magnetic levitation design, you swap that mechanical bearing for 2 neodymium ring magnets pushing away from each other. That completely wipes out the friction and drastically increases how long the whole rig will survive. All in, the raw materials for the generator itself land between $35 and $50, depending on wire thickness and magnet quality. Hook that up to a basic, vertical axis Savonius wind catcher, which you can easily hack together out of a split piece of PVC pipe or an old 55-gallon drum. The entire wind-to-power setup clocks in at under $100. If you want the gold standard in DIY plans, Hugh Pigot's Wind Turbine Recipe Book offers the most rigorously tested blueprints for these Axial Flux setups, spanning from small 1-meter rotors all the way up to 4.2 meters. You can also look into the Wind Empowerment Network, a global group that actually teaches people how to build these. A quick word of caution. Steer clear of dirt-cheap, unverified magnets shipped from random overseas sellers. If those magnets are weaker than they claim to be, the uneven magnetic pull will violently shake your rotor, throw off your voltage, and wreck the machine fast. Spend the extra $3 to get properly graded, coated magnets from a domestic supplier who tests their inventory. Putting this together doesn't require a master's degree in electrical engineering. If you can handle a power drill and a basic soldering iron, you are good to go. Wrapping the wire coils just takes a little patience. Slicing up the steel plates takes a grinder or a quick trip to a metal shop. Anyone following Pigot's instructions can usually knock out the generator over a long weekend and spend one more day putting up the rotor and pole. You just need a tape measure, decent attention to detail, and the discipline to read the instructions twice before you start hacking away at materials. Now, let's ground this in reality. A $40 DIY generator won't magically run your entire 4-bedroom house tomorrow. At its absolute best, spinning in a solid 10-mile-per-hour breeze, a small setup will push out between 50 and 200 watts, depending on its size. That is enough to run your fridge. That keeps a cabin's LED lights glowing brightly. It easily tops off your electronics every single day. It will not, however, power your central AC. If you want whole home power, you need to scale up the rotor size, build a much taller tower, and add a battery bank. At that point, you are spending hundreds of dollars rather than tens. You also have to respect your environment. If you are stuck in a packed city surrounded by concrete high-rises, you don't have wind, you just have choppy turbulence. Throwing a micro turbine on a city roof will usually slash its power output by more than half. This gear shines in rural, open, or coastal areas where the air flows smooth and uninterrupted. If your house is buried in a valley surrounded by towering oaks, you might be better off building a micro hydro setup in a nearby stream instead. This little machine is born from 2-century-old science. It relies on a supermagnet that scientists across the globe simultaneously discovered in the 80s. It harvests usable electricity from a breeze so gentle you barely notice it. It costs less than filling up your car, burns zero fuel, and yet the massive regulatory machine controlling our energy sector completely ignores it. There are no rebates, no tax credits, and no official guidelines for it. A lot of this technology lives completely outside the sandbox built by the modern utility giants. Not because the inventions don't work, but because the corporate model relies on you needing certified technicians, expensive maintenance contracts, and a monthly bill that never ends. A machine you build on a weekend and never pay a dime to operate simply breaks their business model. If figuring out how to generate your own power without asking the utility company for permission is something you care about, sharing this information and joining the discussion is the best way to keep this knowledge spreading. Before you go, I am really curious to hear your take on this. Let's say your property had both a strong, flowing creek and a perfectly clear windy hill. Which project would you tackle first? A micro hydro-magnet generator for a continuous, steady trickle of power, or a floating maglev wind turbine for those big spikes of high output? Let me know your choice down in the comments. And just one final thought to leave you with. Those ancient clay windmills over in Iran have been crushing grain using nothing but the breeze for a solid 1,000 years. No wires, no service vans, and no replacement parts shipped from a factory. If thinking about that doesn't make you extremely frustrated the next time you open a hiked-up electric bill, nothing will.